Good morning, student. Today I want to solve exercise
This is
5.
a question. Prove that fx is equal to mod x minus 1 for all x is element of R. Fx is not differentiable at x equal to 1. So how to check differentiability of any function at any point? First of all, find left hand derivative at that point, then find right hand derivative at that point. If the left hand derivative is equal to right hand derivative, it means function is differentiable at that point. Okay, so first of all find left hand derivative. So limit fx minus fc divided by x minus c as x tends to c negative, and right hand derivative is equal to limit fx minus fc upon x minus c as x tends to c positive equal to. So first of all find left hand derivative. So limit x tends to x equal to 1. We have find differentiability at point x equal to 1. So 1 negative x minus f1 upon x minus 1. This can be written as limit as s tends to 0. In place of x we put 1 minus h. f1 minus h minus f1 divided by 1 minus h minus 1 is equal to limit h tends to 0 f1 minus h. Fx is equal to this. So f1 minus h means mod 1 minus h minus 1 minus f1. F1 means value of function at x equal to 1. So 1 minus 1 divided by minus h. So we get limit h tends to 0, 1 cancel, mod minus h minus mod 0 divided by minus h is equal to limit mod minus h upon minus h. We get minus 1. Here limit as h tends to 0. So left hand derivative is equal to minus 1. Now find right hand derivative. So right hand derivative is equal to this. Now find limit x tends to c positive. Here in place of c x equal to 1. So x tends to 1 positive. X minus f1 divided by x minus 1 equal to limit h tends to 0. In place of x put 1 plus h. So f1 plus h minus f1 divided by 1 plus h minus 1 equal to limit as h tends to 0 f1 plus h. f1 plus h. So here mod 1 plus h minus 1 plus here is minus f1. f1 means value of function at x equal to 1. So put x is equal to 1 means 1 minus 1 divided by h. Next limit s tends to 0. Here 1 minus 1, so only mod h minus mod 0 divided by h. So limit as h tends to 0, h mod h means h minus 0 divided by h, we get 1. So right hand derivative is equal to 1 and here left hand derivative is equal to minus 1. So since left hand derivative at x is equal to 1 is not equal to right hand derivative at x equal to 1. Means both left hand and right hand derivative is not equal, hence fx is not differentiable at x equal to 1. Question number 10, prove that fx is equal to greatest and less than 3 and greater than 0. Big bracket x represent greatest integer function. Fx is not differentiable at x is equal to 1 and x equal to 2. So here we have to prove that given function is not differentiable at x equal to 1 and x equal to 2. So how to find it? So first of all, we find left hand derivative at x equal to 1, then right hand derivative at x equal to 1. If both derivatives are equal, then function is differentiable at that point, otherwise nothing. So first of all, find solution at point x equal to 1. So left hand derivative is equal to limit of fx minus fc divided by x minus c, and x tends to c negative. C means the point at which we find derivative. So limit x tends to 1 negative fx minus f1 upon x minus 1 equal to limit h tends to 0. In place of x we put 1 minus h, f1 minus h minus f1 divided by 1 minus h minus 1 equal to limit as h tends to 0 f1 minus h. Here greatest integer 1 minus h minus greatest integer of 1 divided by minus h. Clear? Equal to limit as h tends to 0. Greatest integer of 1 minus h. 1 minus h means less than 1, slightly less than 1. So in this case, greatest integer means less than integer less than or equal to. So in this case, greatest integer of 1 minus h 0 minus greatest integer of 1 already 1 divided by minus h. So here limit h tends to 0 1 by h. So when h tends to 0, not defined. 1 by h not defined. So left hand derivative is not defined. Now right hand derivative, limit of fx minus fc divided by x minus c as x tends to 1 positive equal to limit x tends to 1 positive f x minus f1 upon x minus 1 equal to limit for right hand derivative h tends to 0 f1 plus 1 plus h minus f1 divided by 1 plus h 1 plus h minus 1 equal to limit as h tends to 0 f1 plus h. So fx is equal to greatest integer of x means greatest integer of 1 plus h minus greatest integer of fx means greatest integer of x. So f1 is greatest integer of 1 divided by h is equal to limit here greatest integer of 1 plus h. 1 plus h means slightly greater than 1. So in this case, greatest integer of this function 1 minus greatest integer of 1 divided by h as h tends to 0. Limit 0 upon h as h tends to 0 means 0 by h means 0. So right hand derivative is equal to 0. Here left hand derivative is not equal to right hand derivative at x equal to 1. Hence fx is not differentiable at x equal to 1. Similarly, we find at point x equal to 2.